if I examine a name of a particular atom that is provided as such here, hydrogen 2, so that is indicating a hydrogen atom with a mass number of 2. Let's just make sure we're very clear on what that is for all of these. Then the way I would draw its symbol is to take its atomic symbol, which is the H, and attach to that the atomic number on the bottom left and the mass number on the top left. That's generally the way that that works. Mass number in both of those places, atomic number, which, as I mentioned, you may sometimes see left out because it is kind of redundant. If I know that it's a hydrogen atom, it better have an atomic number of 1, but otherwise, if you happen to see that number in the bottom left, that's what that is. Now, if I want to ask myself what's in this atom, let's remind ourselves how this works. The atomic number, we said, was the number of protons. So this atom is going to have 1 proton because its atomic number is 1. Right? As far as neutrons, well, it needs enough neutrons to get up to a total of 2 for the protons and the neutrons. So the fact that it's hydrogen 2 doesn't mean that it has 2 neutrons. It means actually that it's got 1 proton and 1 neutron, so that the total is 2. So again, 1 plus 1 equals 2. And that's the idea right there. So that's what we're looking for. Lastly, we said in the last video that unless I tell you you're dealing with an ion, a charged atom, you can always assume the number of protons and the number of electrons are the same. Those should also both be 1. Hydrogen being an atomic number of 1 makes that a 1. It being a neutral atom means this also has to be a 1. Let's try this a little quicker here with aluminum 27. So aluminum, if I look it up on the periodic table, has the atomic symbol Al. You will find that its atomic number is 13, and the mass number is given to you here as 27. Notice you might see a different number in the periodic table block. Don't let that distract you. The atom is what I told you it is. We're going to talk a bit about what that number means in our final video. Once we know that this is aluminum 27, we can see that because it's aluminum at all, that there must be 13 protons. But because it's aluminum 27, I've got to have 14 neutrons, so that this plus this equals that 27. Lastly, because I have 13 protons, and as far as I know it's not charged, I have 13 electrons. I'm going to ask you to pause the video and do sodium and bromine yourself. Okay, and now that you're back, sodium 23 should have 11 as its atomic number, 23 as its mass number. That means 11 protons and 11 electrons, but in order to make protons plus neutrons equal 23, we've got to have 12 neutrons. Lastly, looking at bromine, this is bromine 79, so atomic number of 35, mass number given 79. 35 protons, also 35 electrons, but to get 35 plus something to equal 79, we do a little subtraction and you should come up with 44 as the necessary number of neutrons. We're going to go down to the bottom of this sheet right here, or at least the middle of it rather, just a little underneath, and try this in reverse. And we're going to build the symbol in this case for an atom that has 3 protons, 4 neutrons, or 7 protons, 10 neutrons. In each of these cases, assume it's neutral, assume that it has just as many electrons as protons. You'll notice electrons don't feature in the symbol unless it's an ion. So we can get away with making these just with this knowledge right here. Pause the video, take a moment, and take a whack. All right, so a reminder, in each of these cases, this is telling me that the atomic number is just simply 3 or 7 or 15 or 46 for each of these. The mass number is going to require me to do a little bit of addition. I've got to add up 3 and 4, so this is going to be a mass number of 7. This atom will have a mass number of 17. This will have a mass number of 31. This will have a mass number of 106. So right off the bat, I can at least put those pieces in for each of these. Right? I'm going to have mass number 7, atomic number 3. Mass number 17, atomic number 7. Mass number 31, atomic number 15. Mass number 106, atomic number 46. Move that up a little bit. And now for each of these, all that's left to do is look in my textbook and look at the periodic table of the elements and find the symbol that corresponds to the atomic number. So atomic number 3 is lithium, Li. Atomic number 7 is nitrogen. Notice this is a different version of nitrogen, though. The one I drew for you had just 7 neutrons. You can have versions with other numbers of neutrons. They are still considered nitrogen. Element 15 is P, phosphorus, and element 46 is Pd, or palladium. That one, not so common in biological contexts, but the silver and the cadmium right next to it are worth knowing, number 47 and 48. Now, we've alluded briefly to the idea that there are different versions of each element that have different mass numbers, that have different numbers specifically of neutrons. For instance, nitrogen here we already saw looking like this, and there's also a version of nitrogen that looks like this. We refer to these guys as isotopes. When you have several atoms with same atomic number, but different mass numbers. We're going to investigate them in the final video for this week when we talk a little bit about natural abundance and what that number in the periodic table that has the decimal places after it actually means to us. See you there.